So in this video we are going to discuss about SR Latch. So what is SR Latch? I think all you know about this. If you don't know about the SR Latch design, so you have comment on it. I make separate video about the SR Latch. Till now for designing the SR Latch I just give the overview of the truth table. So truth table SR in the present state, in the next state. So 0 0 have the 8 combinations you get. 0 1 0 1 1 0 1 1. So these are our combinations here, you can observe. So first whatever the present state, there is a no change, it is the no change state. So next it is the reset state. So for the 0 0 reset state. So next 2 will be the 1, so it is the set state. So next will be the invalid state. So we don't know whether what is the output, so it is the invalid state. So according to that we are going to design the SR latch design. So see how we are going to design. So module followed by module name. So it is a latch, by mistake I followed by flip-flop, so you can change it. So you can write any module name. So SR. So input, whatever inputs we are going to enable. So whenever the enable pin is going to be 1, then only your latch is going to be work, otherwise it is not going to be work. So restart. So reset, in phones we are see that what is a reset like that. So if you are going to reset means it starts from beginning, so it's not continuous, so it starts from beginning. So when you are giving your reset equal to 1, so your flip-flop is going to be starts from 0, means assigning from initial state. So SR our input, so SR our inputs, and output will be the next state. So here we are using always block, that's why you make your output port as reg data type. So what are the variables we are using in the always or initial block, that much should be reg data type, so that's why we make it as a reg. So always at the rate sensitivity list, so it star represent the whole inputs. If any change in at least one input also, so it is going to be executed. If there is no change in the input, then it is not going to be executed, so it means of star. So begin. So if reset, so what is the reset? So if reset value is going to be 1, so if reset means if value is true, 1 means, so then Q means our next state is going to be 0. So whatever the condition, it doesn't care, it simply go to 0. So else, if reset equal to 0, if not reset, so then what happens? So else enable. So if your latch is going to be enabled, your enable pin is 1, then only you are going to be start the latch is going to be work, otherwise it is not going to be work. So begin. So case, what is going to be done? So in case what are the variables you have write, we have to give the values assigned here. So SR, so these are the variables we have to write like this in square brackets. We are going to give. So 2 means SR, so means we have to concatenate these two, means combining. So first bit is going to be assigned to S and second bit is going to be assigned to R. So 2 tick, so it is a 2 bit, so that's why you represent 2 tick, it means binary, so B. So 0 0 0 1 1 0, other case it will be going to be invalid case. So see, if the SR values are going to be 0 0, then what is your output? So no change, means what are the Q value is going to be assigned to the Q value. So Q is equal to Q, you can see. So if the SR value is 0 1, so what is the value? So whatever the Q value, it will be assigned to 0. So you can simply write Q is equal to 0. So if your SR value is 0 1 0, so see the SR value is 1 0, so whatever the present state, it doesn't care, it simply our next state will be 1. So you can simply write 1 here. So default. So if in other case not 0 0 0 1 1 0, so your automatically your state will be defaultly go to don't care condition. So you can simply write this. So case will be end case. So whatever the begin you written here, it will be end with end keyword. So here always begin is there, so that's it will be end with end keyword. So module is end with end module. So it is our design code. Up to now is it okay? I think so. Just move to the test bench. So module followed by module name. So it is our identifier. We have whatever the module name, you can say it as a identifier. So what are the inputs we are make it as a reg data type. So what are the outputs, we make it as a write data type. So why you are using reg data type for input means, so what are the variables you are going to use in the initial block or always block, that must should be reg data type. So that's why you are going to be assign our inputs as a reg. So here you can see the port connection. So we have to connect the design code with test bench code. How you are going to connect? By using these lines. So whatever that means, we have to instance the design code in the test bench code. How you are going to instance? How you are going to connect means, so you have to write the design code name. So whatever the design code name, you have to written here. and followed by instance name. DUT means design under test. You can write any name, it is simply an instance name. So followed by port list. You can connect port by order or port by name. I already done the port connections video in previous videos. If you don't watch, go through that. So if less number of input and output ports, you simply write by port by order. So initial begin. So in the initial begin block, so initial block we are going to give the different combinations of input. So you are giving different combination of input whether your design is correct or not. So if your output is going to be correct, so then you are going to design whatever you are going to design is correct. So if your output is wrong, then there is some mismatch or some any wrong we have to done. So you have to verify. So first what I have to done. So according to the steps I cross verify the waveform. Just carefully observe. So it is a sequential circuit. So it is quite different to understand the waveform and little bit tough than combinational circuits. So first your enable pin is going to be 0. Initially our enable is equal to 0. So what happened our enable is equal to 0? So see here. So initially so don't see these values. These values is whatever the yellow line is drawn here. So those values is displayed here. So just observe this green line. So enable is 0 here. So your reset value is going to be 1 here. So enable is equal to 0, reset is equal to 1. So our S is equal to 0, R is equal to 1, and our Q is equal to 0. So I said that whenever the reset value is going to be 1, so see whether design. So first whenever the reset value is 1, then it completely going to be this execution only. You all know about that. If condition is true, then it doesn't go to else statements. So whenever the if statement is false, then only it enter into the else statements. So first it check the reset. So reset value is 1. So if statement is true, then it directly assign Q value is equal to 0. So it doesn't execute the else statement. So that's why our output is directly going to be 0. Here we can observe. So next observe. So here we can give some delay, 5 nanoseconds delay. So 0 plus 5 is equal to 5 nanoseconds. So see here in the waveform. So next it is a 5 nanoseconds. Like that we have to observe the waveform. So after 5 nanoseconds, whatever the inputs, so enable is equal to 1 and reset value is equal to 1 and SR value is previous only. S is equal to 0, R is equal to 1. Here also you can observe whatever the enable pin, it doesn't care because first the if statement is going to be executed. So what is our if statement? If of reset. So if of reset is correct, so then we directly execute the if statement, not else statement. So again our Q value is going to be 0. So next after again you give some delay. So now your reset is going to be 0. Reset is equal to 0. So in design code, so this statement is if whatever the if statement is going to be false. So then it go to the else statement. So 1 minute I can erase these all. So next time you can understand properly. So whatever the reset value is 0, so then if statement is going to be not going to be executed. So then what happens? So here what are the values I given? S is equal to 1, R is equal to R is equal to 0. So 1 0, what is the combination we are going to get? So 1 0, our next state is going to be 1. So see in the waveform whether your Q is going to be 1 or not. Yes. So our Q is equal to 1. So until now it okay, fine. So next what are the combination you can observe? So again see after 5 nanoseconds delay I give 1 1. So 1 1 combination what you are going to get? So our 1 1 combination you are going to get the don't care condition. So you can cross check the truth table. So after 5 nanoseconds is going to be don't care. So after again 5 nanoseconds 0 0. So 0 0 what I give? Q is equal to Q, means what is the value of Q is going to be assigned to the Q. So what is our Q value here? Don't care. So this don't care is going to be assigned for the next state also. So present state is going to be sent to the next state. You can observe, so don't confuse about this. So whatever the previous value of Q, it is going to be assigned to the now also. So again the combination is 0 0, after that it will be 0 1. So 0 1 combination, what is our value? So you can cross check the truth table. So 0 1 it is going to be 0. So now go to the waveform and check. So here Q value is equal to 0. Like that you are going to verify. So after some delay you can finish, means you have to stop the simulation here. So and module and with end module. Like this you can cross check your whether your waveform is correct or not. So what are the inputs, you are getting the correct values of your truth table according to your truth table or not. You can cross check like this. So I think it's fine about the waveform. So thanks for watching. If you have any doubts you can comment on it. Until then, bye.